Hello Saitan, hope everyone's having a great week. I'm just filming this video as part of our experiment that we're going to be doing on Thursday. So the experiment we're doing is essentially what's going to happen is that we're going to be sliding a couple of cards that I have down a ramp, right? So pretend that where my pencil pointer is, we're just going to slide a couple of cards down the ramp, and then we're going to measure the displacement and ultimately calculate our velocity and as well as our acceleration. For this experiment here, I'm going to be asking for the three different experiment variables. So the first two should come pretty obvious, should come easy from your notes, as I'll be providing data tables that tells you exactly what they are. I'll just help you out with the third one, which is the control variable, right? So the control variable is the things that you keep constant. In a real life assignment, in a real life experiment situation, you're only allowed to change one thing in order for the science experiment to be accurate. So in this case, we are changing the time and getting displacement results as a result of our changing time. And the things that we keep constant is that, for example, we're keeping the same starting position. So I'm always going to have the back wheel to the very edge of the ramp, and I'm going to have the same height for each ramp, right? So what's going to happen is that I have a binder holding up the ramp, and the binder is approximately 9 centimeters in height. And another thing that's common is that we're going to keep the same time intervals, right? So I'm going to measure in 1, 2, 3, 4, and 5 seconds. Before we start the experiment, I just like to take this time out to kind of make some connections between math and science, because sometimes I hear people saying why do we do this, right? So for example, I picked this lab because this is a great example for me to illustrate the connections between math and science. So this triangle here, most of you probably known this as a ramp. For example, maybe you like to go skateboarding, or you like to go BMXing and go on a ramp and then make a nice little jump. But physicists call this an inclined plane. So an inclined plane is like this, right? Notice the shape of this, right? So this is, right, it's a triangle, right? So remember last year when you guys learned about SOHCAHTOA and SOHCAHTOA? So this is where your math trigonometry skills comes into play, right? So next year for Physics 20, if you do decide to take that, you will start to calculate things two-dimensionally, right? So what that means is that next year, when you take Physics 20, if you do decide to take Physics 20, you're going to calculate something called a net force. That's what we call F-net. And F-net is, for example, for an object here, is determined by this. So you have this is what we call a normal force. You have a force due to gravity. And then you have what we call the frictional force. And oftentimes right, so it's your job to calculate F-net. So F-net is often determined in both the X and Y direction. And to calculate, for example, the vertical component of the force due to gravity, you're going to do something called this. Right? And you recognize that this is one of those trig ratios that you learned in grade 9 math, right? So here's one of the examples where math and science come to play. And also, if you go on to university, university level physics, you're gonna talk about things in three dimensions. So high school, we keep it as 2. University, you're gonna talk about 3. And if you do have to take even a higher level of physics, you're gonna take a look at things in 4 dimension, where it's also relevant to time. And okay, so I'm going to end this video now and actually talk about the setup of the lab.